All right, well, thank you for coming to our session today. We're going to be talking about how Vuforia uses artificial intelligence in augmented reality applications. My name's Brad Pitzer. I'm the Director of Product Management for our Vuforia Engine product, and I'll be co-presenting with Pete Messenger here. He's a senior software developer for our Unity and Tools group out of our Vuforia office. Peter has worked on countless number of games in the Unity platform before coming on to PTC and starting to work on our integration with that tool. Myself, I've worked with a ton of amazing developers like Peter in the games, augmented reality, virtual reality industries. I've worked with LucasArts, Pixar, and THQ on developing mobile AR, VR apps, as well as a whole bunch of companies throughout the world doing automotive, aerospace, and defense type applications. So just a quick, always have to do this obligatory question. I can't really see everybody out there, but how many people are actually developing augmented reality apps currently? A lot. Okay, that's good. That's great. And how many people have developed augmented reality apps with Vuforia? Okay, that's a great thing. Okay, well, good. So it's great for us to see that. We've actually had some very positive feedback just the one day that we've been at the show so far, and actually had a couple people come up to the booth yesterday and say, like, before I start asking you questions, I just want to thank you for Vuforia, which is a great testament for the amazing work that our developers are doing. It just kind of validates the direction that augmented reality as an industry is going, as well as what we're doing in the Vuforia group here. So, first simple question, you already know this because you're here, and from the hands shown, it looks like a lot of people are already doing augmented reality apps. So augmented reality, just kind of as the name implies, is that we're augmenting digital content onto the real world. It could be in the form of text, images, animations, 3D data, and that's great. We kind of already know how to do that. We've been doing that for over 8 years now with Vuforia Engine. And, the purpose of what we're going to be talking about today is really how artificial intelligence is used by Vuforia in your augmented reality applications. Kind of a mouthful there. So what is artificial intelligence? In its simplest definition, it's the development of tools, basically software in our case, that process information like humans. Humans process information using each of our 5 senses. And it's kind of interesting to note that the first 3 here, the taste, smell, and touch senses, make up a very, very small percentage of how we perceive information. Hearing itself actually takes up about 8 to 11%, and then everything that we see through the cameras, or our eyes, is actually makes up about 80 to 90% of how we process information in our brains here. So this is how we assess the environment around us and how we can, I guess eventually, augment digital information onto those environments, okay? So in processing that information, the effort required to transpose digital information to a physical space creates a cognitive load on a person, which sometimes can reduce the way you perform tasks, for example, driving. And so when we dive deeper into that, how do I process that same information in different scenarios? So basically, I'm driving through the Malibu Hills on a sunny day in my convertible Porsche, or it's raining outside, I'm driving along a rural highway in an 18-wheel trailer. They're technically the same thing, but they're also extremely different. So how do we process that information differently? So we'll come back to that, okay? So computer vision, which is what Vuforia Engine is what makes AR work. And it acts as kind of the eyes of your applications that you're developing in Unity in this case, and assesses the images that come in through the camera of your devices, head-worn or handheld, and allows you, the developer, to place digital content in context of those environments. So Vuforia Engine is a software development toolkit that allows you to apply advanced computer vision to your applications. This vision is the eye of your application, and it lets you see and understand the world through the device's camera, and allowing you to place digital content in that context. Vuforia Engine has been around, I think we're almost, we always say 8 years, but really closing in on 9 years at this point as an SDK. And we have over 850,000 registered developers. There's over 70,000 commercial apps available. And we're closing in, I think, on just under 1 billion actual app installs, which is incredible. Okay. Using Vuforia Engine, which has been around for a while, our company, our parent company, PTC, has created a whole suite of augmented reality or computer vision-based products. There's standalone SDK tools such as Engine that many of you have used, but we also have some standalone authoring tools that allow you to create content, without necessarily having the need to program it. Okay. So there's many different ways for us to attach content to objects. We call these target types. And Vuforia supports a whole host of these. Everything from what we call ViewMark, which is kind of like a pretty QR code, to image targets, to multi-targets, which could be multi-sides of a box or like a box of cereal or something like that. Cylindrical targets, object targets, and then one of our latest releases, which is model targets, which uses actual CAD geometry. So in its simplest form, and probably the most common, certainly from our perspective, a majority of our customers use what are called image targets. And that could be just an image in a brochure, a poster, a book, something you printed out on a piece of paper. And it's it's just a really easy entry into augmented reality, a very simple way to do it. Usually people have a piece of paper and it pops some 3D data on it, and you can do some animations and have fun with that. But you could actually place that image on the side of an object and track it in place. And with kind of precise measurements, you can actually augment onto the actual object itself. It has its limitations because once that image is kind of out of view, you start kind of losing tracking to a certain extent, so you could have some issues with that. We have something called extended tracking that helps with that, but there are limitations to what computer vision can do in that case. Another concept here is a ground plane target, and that's great. It allows the camera of your device to assess the world around you, find planar surfaces, and then put digital content onto that. The con to that is basically that you can't actually place that object or that virtual object in the context of the real object. It's very difficult when you have a ground plane target to line the two up, okay? So we've created what's called a model target. And this is basically takes the actual CAD data from your object that's been designed by a company, whether it be a vehicle, a coffee maker, a Lego set, or whatever, and allows you to use that to recognize and then track to that actual object. Okay. Amazing. All right. So very simply, the model target uses either a guide view, or what we'll be showing you is kind of what we call markless tracking, to guide the user into lining that object up. Once it's actually lined up to the physical object, our standard tracking techniques, I guess, kind of take over. But it's without a doubt the most robust way to do tracking. Okay. Yep. Okay. It's going. So this allows you to basically point your camera at an object and just go. So you don't have to have markers. You don't have to have anything that kind of signifies what you'd be doing with that. You just point your camera, it recognizes the object, and then triggers whatever kind of event, whether it's some kind of animation, overlay, product information, disassembly, you name it. Okay? Something that we introduced at the beginning of this year is what we call advanced model targets. We keep iterating this feature because we find it extremely powerful, and the customers that are using it are doing amazing things with it. But the idea behind model targets, or advanced model targets, especially advanced model targets 360, is that you can approach an object from any angle, point your camera at it, and go. So the idea is I walk into a car showroom, and I don't know if the user is going to be coming in from this side, the front, back, side of the vehicle. All they have to do is point their camera at that car, and then up will pop up all of your digital augmented reality experience. Okay. Oh, never did the movie, sorry. This is we're actually showing this in our booth, so if you're interested in coming by and asking a little bit more about how this works, more than happy to show this. But again, like I said, you can really approach this vehicle from any angle, and you're off and running. One of the things that I've had several people come up yesterday in our booth and ask, how is this, or is model targets the same as object targets or object tracking in ARKit? And the answer is no, they're very different. Within ARKit for object tracking, you basically use your camera, your device, to scan that object, and it recognizes it, but it isn't actually recreating any kind of 3D data. And it works really well. We have a similar concept called object targets within our suite of, within our SDK as well, called object targets. Very similar thing. We released this about 5 years ago. And again, you use a phone app to scan the object, and then it retrieves a bunch of information through the photographs that are captured in the app and allows you to track to that. It's great when you don't need exact precision on a smaller object, on a larger object, or whatever. But this is kind of where the model targets feature kind of came about. So in our advanced model targets, we train the CAD data to be recognized by your application and then lock onto that. We take the actual CAD file of your object and run that through a million random background images, different lighting conditions, different poses or angles that the object might be in, different colorizations of the actual object itself. And this allows a neural network file or database to be created that you input into your application that allows that object to be recognized in most situations, 99.9% of the situations you might have. And the great thing about that is you really can't predict what your users are going to be doing and how they're going to be approaching an object. And so this allows you to kind of get into that. So looking at the data flow or the workflow of advanced model targets, I was going to do a hands-on demo. We had a little bit of technical difficulties here with the display on my computer, unfortunately. But the idea is that you would, with what we call a model target generator, we have an application, a Windows-based application, and I'll show some images of that here in a little bit, allows you to create this model target, send that up to a cloud hosted that does kind of our processing for the neural networks or deep learning. And then that database is downloaded back to the local machine, and then you bring that object into your Unity project. Okay. So this is kind of basically an example that shows that you can view this and many different objects all in the same application. It will basically recognize those no matter where they are, what they're doing, and you can apply your digital content to it. Okay. So what has been the impact of artificial intelligence and augmented reality? So there's limitations. The computer vision being used in augmented reality today does amazing things, and there's just certain things that you can't overcome sometimes, and that has to do with lighting conditions, how the user is approaching an object, how they might be moving their camera once they've actually locked on, and all the different things that users do that you could never possibly predict. And so what we hope to have happen with model targets is that we can not only recognize that object very quickly, lock onto it more robustly than we ever have before, but also when you do lose tracking, I mean, and it can happen. Let's say a kid is looking at a Lego set and they move their camera, or they're jumping around or doing whatever. You might lose tracking. You can very quickly relocalize to that object and begin tracking again with very little kind of lag, I guess, in between the experiences here. Oop. Let's start automatically. Oh, guess we're not watching that video, sorry. Well, if you guys have walked around the show floor, I think there's several places, including our own booth, where we're showing that Lego demo, and it's really impressive what Lego has done. And they continue to be extremely innovative with our products, which we love. So not only, companion product apps such as Lego sets, but even doing things on larger objects with cars. We have customers that are doing this on large aircraft for service and maintenance type applications. And it's just a great way to engage and experience these products. Okay. All right. So, quick summary. Basically, we're using with our model targets, target applications, or a feature is creating a neural network, for the objects that trains the CAD data. It's the most accurate and robust way to actually track augmented reality to an object. And of course, you have to have accurate CAD data. I've had a few people that also came up and said, "What if I don't have the CAD data?" Then it's hard for you to use model targets, obviously, because that's what it's based on. But it's really meant for those kind of customers that require that actual precision, that you want the overlay to exactly match everything on the actual real object itself. And we have, many customers that have CAD data that has all sorts of variants and options and different things. And again, that can cause issues with not so much the tracking, but really how the content is overlaid. So we have, we'll have them either redo the CAD data or make sure that we have the right configuration for the product that we're actually augmenting in that particular case to do that. So get into this here. So this would have been the hands-on demo here. But we have a tool called the Model Target Generator. And the Model Target Generator allows you to bring a CAD model in and set the pose, basically, of your CAD model, depending on the type of target or model target that you're going to do. We have one that doesn't use a deep neural network, that allows you to look at an object with a specific guide view. So that means you're going to approach the object in a specified way that guides the user into that experience and allows you to lock on and start tracking. The other side of this is where you actually create. Let's see. There we go. You can actually create multiple poses for that object, and you can actually train the object from multiple angles, and that way you can have somebody approach from one side, you can trigger one type of content, you have them approach from a different side, and that triggers a whole different type of content. With a Model Target 360, obviously, you really only have one choice. You're not actually going through and deciding what pose or what angle, what view that you're going to have your user view this at. It actually just will train the entire model from every angle and generate a neural network file or database for that particular object, and then allow you to bring that into your Unity project. On the Model Target Generator, you can bring in, most of the native CAD data formats, such as CATIA and our own CAD project from PTC, or CAD product from PTC called Creo, as well as all the different generic formats that you see here: OBJ, FBX, STL, IGES, etc. Okay. So with that, I'm gonna bring Peter up here. We're gonna do a quick hands-on demo once I had created the actual model target. This would be the next steps of bringing that into your Unity project.
All right, so this is actually a hands-on demo of getting Model Targets 360 into Unity. So we would have generated a database, and then I'll show you how to import it and get a model target in Unity here. So the first thing is we'll have to get Vuforia into the project. Vuforia is currently a package, so you can find it in the package manager. As you can see, I've already installed it, so I have the remove button instead of the install button, but basically you just have to click install, and it would import a couple assets, and you'd be good to go. And you can tell that you have a Vuforia in your project because now in the game objects menu, you have the Vuforia Engine submenu item. So I'm just going to add an AR camera to the scene, and I'll get rid of the original default camera because we no longer need that. And what we have now is basically just a standard Vuforia scene where I have the webcam hooked up here, and you can see, we just get the video stream from the webcam. So another thing I'll show you really quickly is, right here, there's a license field. For this demo, I'm not using a license, but this is where you would paste your license with model targets. And there's a couple other things that you can configure, but actually, for model targets, we don't have to right now. So let's get the data set that was generated. I have it generated previously. It's just a .unity package. As you can see, it's going to import a couple files. The important ones are this stat and XML file. These are the actual data set files. We have a couple others that we use for visualization in the editor. And I'm just going to import those. And now you're all set. You can see it's added to some subfolders here, to the streaming assets, for example. And now I can add, from the same menu as before, a model target. So I'm just going to do that. And you can see the model target show up. And because I only have one data set in the project, it automatically selects it. And this is the bike that I'm going to be demoing here, the motorcycle. And if you look at it, there's this white image here. This is a preview model. This is to give you kind of like a reference for when you want to add some custom augmentations to it. And I'm just going to rotate this so that it looks better. -90, there we go. And this is where you would start, you would get created. You can add any sort of augmentation to this. So I'm just going to add, I have a prefab here. Just going to add that to that. You can see there's some Z-fighting going on because it's basically the exact same model, just textured. I'm going to get rid of the preview model because it wouldn't be rendered anyway. It's just there for editing time. And then I'm also going to have this script that I prepared. It's not important. It'll just do some animation stuff. But this is where you can do anything you want. And yeah, that's it. So I'm going to hit play, and it should, at this point, when I look at the bike, detect it, and then play a little nifty animation right there. Yeah, and just to show you that this is 360, I'm going to quickly lose tracking. I'm going to turn the physical model around, and I'm going to detect it from the other side. And yeah, it's a little dark in here, but it works. So you can see, if you're familiar with previous or the classic model targets, you'll notice that there are no guide views here, as Brad mentioned. So you can just, no matter what angle you're looking from, it'll just snap and work. And that's it. Pretty simple.
Great. That's it. Thank you. We have a couple extra minutes here. Is it okay to do some Q&A? I'll take that as a yes. Anybody have any questions? Are the microphones set up
Hello?
here?
Oh.
Yeah.
During the object identification phase, how many different objects it's looking at the same time? I mean, obviously you had more than one object it's been looking for, like the car, two different cars, and the motorcycle, but what's the limit there?
What's the limit is the question?
Yes.
Yeah, okay.
How many
So-
objects it is
Yeah,
looking
so
during?
obviously what we're showing here is just one object in there. There are limitations. I mean, there's obviously a size factor that becomes an issue at some point. So currently, I don't know, we have, we kind of say as a best practice, we have a soft limit of about 25 objects, so 25 different CAD models. There's other approaches. Sometimes you might actually be using just a subassembly of an entire model. So you might just have like the landing gear. So one of our customers is using, they're tracking to just the landing gear, and then that basically locks on and tracks for the entire aircraft. So you can do things like that too, where you actually recognize from a specific object or subassembly of the assembly, and then experience from there. Mm-hmm.
Hello, I want to ask, what if my object is broken? What if a wheel of my motorbike is lost? Is it possible to recognize that object?
If it's broken, you mean if...
Yeah.
So if the model doesn't look the way you'd expect it
Yeah,
to look?
maybe just a part of the model is look like...
Okay, well, I mean, it's pretty robust. Obviously, if it looks too differently from the original model, we won't be able to, or the computer won't be able to recognize it because it's expecting a certain
I
look.
don't
But
know how much percent?
Yeah.
it's hard to give like a number, I guess.
Yeah, it's really hard to quantify. I mean, we have the Lexus model in our booth today, or this week at the show, and we had people come in and they asked a very similar question. And so what we did is we opened all the doors and we opened the hatchback on the vehicle, and it still was able to track it. And that's obviously very different than the expected object that it was looking for. So it found certain elements within that car or within that vehicle and allowed it to track. I would say that was, a good 50% misleading or wrong on the object itself. But, there's other things that could become a factor. The amount of features, the lighting could even cause issues if it's like really bright sunlight. That can cause reflections that look like lines and things like that. So it just, I think in the model in our booth, it is a happy accident that it does pretty well with all the doors open.
One thing though, but because we're training on CAD data, the texture doesn't matter. Like the color of the bike could be completely different and still work. So that's one of the advantages of our system.
Yeah, go ahead.
Got it, thank you.
Sure. Yeah, just to give you maybe a heads up roadmap, I mean, we are looking into, continuously iterating this deep learning model targets feature. And one of the things that we're doing is kind of exploring it at least as a state-based target. And so what that does is that from a assembly or disassembly or maintenance procedure standpoint, I can predict that somebody's going to open a door, pull out a cartridge, pull a tube out, those kind of things. So I can start looking for and expecting those things to happen. Like, how do I keep tracking when the door opens? How do I keep tracking when that object or that cartridge has been pulled out? So those are things that we'll be doing, as we iterate this feature. I saw a hand up over here. And
Yeah, I've got a question as well.
So one of the
Let's
sorry,
let's
yeah.
go to the mic if you have a question. Might be a little bit easier for everyone to hear. We're actually doing a similar thing with object recognition. But on shoes, for example, we use photogrammetry to scan a shoe and then use a similar way of rotating the lighting, the shoe itself on different backgrounds. And it can detect pretty small changes. So if you have two quite similar shoes, it can still recognize it. This is also possible with your solution. So if you have like two trucks, for example, which look pretty similar, how confident is it that it gets the right truck? Is it?
Yeah, so we have, I don't know if they would be here, but we have a customer that just did a campaign for Puma shoes. The tough part with the shoes is that generally the soft parts aren't modeled. So they'll model the sole, so you get that, but that's really not referenceable, I guess, when you're tracking something. You're only looking at the top and sides of the shoe. But they were able to very successfully get, the left and right shoe. That is kind of what I think you're talking about. There's a subtle difference.
Yeah, we're actually talking about shoes that are almost the same, but not exactly. They have subtle differences.
Gotcha.
But for example, when you have two trucks which are a different model but look kind of similar, how is it? Yeah, how confident is it that it gets the right truck?
I mean, that again is really like kind of a case by case basis. So you're looking at if those features are pronounced enough to be recognized by the computer vision system, and we could even maybe potentially enhance those by turning it. We have something that's called real textures or in the model target generator. You can either turn textures off or turn them on, basically. And so with textures turned on, maybe that is part of the the difference in the two shoes. It might be two different colors or two different materials, that kind of thing. I'd be wrong to tell you, yes, no problem, we could do that, because a lot of times in things like this, you have to kind of test it and see, if that works. With photogrammetry, I mean, obviously that works, but you're getting an approximation of the model. It's not as exact as, as a CAD model would be. So I'd hope that any of those differences would be more pronounced in a CAD model than they would even the the recreation of that model.
All right.
So, it's a lot of words, sorry. Who else? Go ahead.
So I managed to work with model targets on mobile devices, but is the HoloLens also supported?
It does, yes. Yes.
Thank you.
Yep, and especially the HoloLens 2 here very soon. Yep.
Hi, sorry, I just want to ask, do you have a limit on the amount of vertices in the mesh of the CAD model?
No, but I mean, from a general AR best practices standpoint, you want as optimized of a model as you possibly can. I always, from a sales point, our sales guys sell this as a really easy to develop tool. Peter came up here and showed you, how easy it was to actually just set this up as an augmented reality application. But any of you developers know that, probably the most time-consuming part can be the actual optimization of the CAD model itself. I mean, I've seen projects where that takes up more than 50 to 60% of the cost of a project. And so there's lots of different methods of doing that. But if you're looking at, a multi-million polygonal model to run on a, handheld device, or even, on HoloLens, you're going to be sorely mistaken, maybe. So, I mean, there's lots of tricks. Obviously, you're not going to augment the entire model. You might just augment based on his animation that he had up here, but you might just be augmenting that swing arm only. And so that's really the only digital, 3D data that you're bringing into the scene. So, okay.
Hello.
Hi.
So if I were to take a 3D model and then 3D print it and say use the same 3D model to overlay the AR, well, now I have a 3D object, printed object, that it's possibly 0.5 millimeters deviated from the CAD model.
Mm-hmm.
So how would the AR work on top of that deviation?
Yeah, I think that generally works. I mean, one of our sample apps that we provide with the model targets is a 3D printed lunar lander. And so you can 3D print that, and that's what we generally use to showcase this to developers, or to give you at least the code and the process on how model targets work. So, again, there's other things that become a factor with 3D printed objects, depending on the material that you use. So sometimes if you use like a gray or white material, it might actually not show the contrast of the features as well. We generally will use, when we do our demos, we'll do like a yellow material, and that tends to work the best. But there's, again, just depends on the object and the lighting and the environment and everything else. So
Generally, the size of the model we use for scale. So if it's way off, we can still track it usually, but the scale will be off. So it's good to have it as close to physically accurate as possible. But yeah, the system will make sure that it tracks as closely and as precisely as possible still.
Yeah, scale is a good question that comes up a lot too, because we have the Infinity SUV in our booth here, but that also works on a full-size vehicle, QX50 I think is what it is, and because the app that we're using today is scaled to the smaller toy model, but it is accurate model. when you try to do that on the larger vehicle, it works, and it works well, but you might see a little bit of misalignment, just due to scale, and it's not, exact CAD. And to general users, that's okay, but to an automotive manufacturer that's trying to showcase their vehicle and they want to show red, blue, and black colors on their car in augmented reality, they want it to line up exactly perfect and be as beautiful as possible. So, yes, sir.
Yeah, hello. You gave the example of the car model in your booth, and I want to ask, how do you exactly track it with the open doors, for example? Do you have to upload CAD models with different states, or is the tracking so robust that it can achieve that?
I'm sorry, what was the last sentence?
You gave the example with the car at your booth.
Mm-hmm.
And for example, you can open the doors and it still can track. And is the tracking, does the tracking provide such a robustness that it can still track with the open doors, or do you have to upload CAD models with different states of the car, or how does it work?
Yeah. Do you have an answer for that, or?
Yeah, I mean, it is that robust, but it's not actually tracking the open doors, because that's a different problem. That's articulated models. But yes, basically, if it's snapping, it can. That was the question previously, like how far can the model deviate from reality and still be able to track it? Our system is generally very robust, and in certain cases it works, like the doors in this case.
Yeah, if it has the right amount of features, it's going to find the right things. Even with the doors open, it's going to find other elements to track to, and it will recognize and find those.
Okay, yeah. But do you have the possibility to upload different states of the model, or is this planned?
I see what you're saying. Yeah, so I mentioned this earlier as kind of a future roadmap or iteration for this particular feature. Is we're looking at exploring state-based model targets, and so that's very similar to what I was saying with you have different states of disassembly or a maintenance procedure. So, state 1 is everything's closed. State 2 is doors are open. State 3, a cartridge has been pulled out. So we will be recognizing that, especially if you can predict, not only that, but even kinematic linkages and things like that. So.
Thank you.
Mm-hmm.
God,
Yes.
I think you just answered my question.
All right. Okay.
Let's suppose if you're tracking the car, let's insist with the car example, and should the software be able to track that the door was opened? Would it be possible to feed back the movement into the model and keep tracking the door and stuff like that? That's not possible yet, but will be.
Yeah, so, I kind of know the answer to this, but what would be like your use case for doing something like that?
I mean, it will be nice to have the possibility to do tracking on objects that have movable parts and stuff like that.
Yeah, so one of the things that we've been asked by some of our customers is to verify or validate that a particular procedure has happened. So, whether it's opening a door, but really they're more interested, like, has this bolt been put into the assembly, or have they removed this plate, or things like that. And for like validation purposes to say this is being assembled correctly, but the other for, okay, what's the next step I should be showing this user? They've already put the 12 bolts in here. I only showed them how to do one, so now I recognize that those 12 bolts are in. What's the next step after that? That's when we get into really, not far. I mean, we're exploring it. We're testing out some of these things right now, but where to go with this? It becomes very interesting. Mm-hmm. Anyone? Just have a couple minutes left here.
I was wondering if you have like the object tracked, is it possible to offset the model so it can stand like on the side of it?
Yeah, I mean, what we're tracking is basically we're creating a coordinate system. So when I showed you the preview model before, wherever you place your content next to that is where it will appear next to the physical model. So if you want to have it over here, or you want to have like a house or garage or something, you can place it relative to that physical object, and then when you track the object, it'll appear there.
Okay, thank you.
Cool. So do one question here, one question there, and then I think we're going to be done
please
here.
assume we create a CAD model of the car interior. Would your software be able to recognize parts of that interior.
You create the model in what, you said?
Of interior of the car,
Oh, okay.
inside. And then you enter into the car with the phone. Would it be able to recognize parts of the model and orient itself?
Sure. So there's an app already out. It's been out for over a year now. We showed that at AWE last year called Ask Mercedes, and they use that for the interior instrument panel. And it's basically a user guide or user manual for the inside of the Mercedes S-Class. And it will show you how to, run the air conditioner, the radio, all the different features within the interior. You have your standard potential issues with lighting, with not being able to be back far enough to see enough of what you want to see. But you can usually overcome those as long as you're, as a developer, kind of trial and erroring those things. I remember at AWE, we also did something inside the engine under the hood of the Mercedes, and we had to bring in some track lights, basically, some portable track lights to put in there because the lighting was so bad in the area that we were at that you couldn't, was having trouble tracking it. But, those are just things you have to take into consideration when you're designing your AR app.
Okay, thank you.
I have two questions. First one is, can you track two or several model targets at the same time in one camera feed?
Yep. So we say we don't, but we have a video. I've been told not to show it anymore, but we can track up to. In the video, it shows 4 objects being tracked at the same time. Okay. It has a potential to cause issues with doing that, but really it seems to work in most cases. There's just a few scenarios where it might be unpredictable in what it might do, and so that's why we don't necessarily claim to do it, but it seems to work. So,
okay, cool.
Yeah.
The second question was, if you move the physical object in the real world, does it track the update of the position change?
If you move the physical object in the real world, yeah. I mean, it's just looking for the object itself. It's not necessarily you're not modeling the environment. But we have, there's all sorts of scenarios. I'm trying to think of like an example, but there's even places where they have the same model like over and over and over. Like we have this Whirlpool washing machine test facility, and there's 50 machines all running at the same time, and you can go up to each one and kind of look at what they are. And it's a similar kind of thing of like looking at something that's been moved, but in general, it's just looking for the object itself, not necessarily where it was placed.
Okay, thanks.
But we don't officially support moving objects. If this were to drive, the tracking would not work well. That's not what we support. In certain cases, it actually does work because the tracking is so robust, but officially we don't support moving.
We do it.
It's, if it works
Again,
then we promise that's great. But basically, it's.
If you come into the booth and you take the Infinity car and you drive it around like a kid or something, it works. I mean, we have other places where they have toy cars and they drag race them, and it seems to track pretty far. We do have a new feature that just comes out next week, that is static and adaptive modes of model targets. And with static, it sets certain parameters for just a model that is never going to move. It might be a giant machine or something that isn't going to move. And then the adaptive allows that object to have some motion. It just sets parameters differently. We can't promise that it will work while it's always moving, but it seems to do extremely well. So that's something that actually comes out in our 8.5 release October 1st.
Thanks.
Sorry.
All right.
All right. We're good. Thank you very much, everyone, for coming by. Appreciate it.